Hello there, I'm back again with physics. Introduction to physics still, just a few ways of manipulating formulae when it comes to changing subjects or formulas. Physics has got quite a number of formulas. So I'm having two formulas there which are coming from equations of motion. They are actually equations of motion coming from the topic of kinematics or linear motion or classical mechanics. Therefore, the first one is simply having velocity as its subject. The second one is also having velocity, final velocity in this case, as its subject. So in the first one, I've written there to say you make u, therefore initial velocity, this is final velocity. Let's just call them by their names. That's v, u, at. Make u the subject. To make u the subject means to make u, to solve for u, to solve for the letter u, to solve for this symbol u. So how do you change this formula to make u the subject? There are a few rules that you have to learn from your mathematics, but I'll try to do one or two things to simply refresh our minds, because I know you have been, somehow you should be taking mathematics. So we've got v is equals to u plus at. So to make u the subject, I'm going to say v, I'll transpose these to the other side, minus at is equals to u. Okay, then this can also be written as u is equals to v minus, at. I've made u my subject. If I want to make a my subject from that formula, v is equals to u plus at. Okay, I'll simply transpose u to the other side, where I'll have, when I transpose this, its sign is going to change. This is positive u, it's going to be minus u, okay, equals to at. Then I'll divide, since this is multiplication, I'll divide by t on both sides. Therefore I'm going to say over t, then these t's will cancel out. Then I'm going to have a is equals to v minus u over t. Remember, this is the same as writing v is equals to u over t is equals to a. So the two are the same, but this one is better when it comes to proper solving, because it goes with your right hand, and it's always best. The second equation there is where we have to make x, or displacement or distance, our subject. So we'll say v squared is equals to u squared a to ax. This comes from algebra. How to change subjects or formulas comes from your algebra topic in math. So I'm going to find a way of transposing this. So I'm going to have v, this is the positive u. When I make it cross the equal sign or transpose it, I'm going to have minus u squared is equals to 2ax. Then I'll divide by 2a on both sides, 2a over 2a. Then the 2a will simply cancel out. Then I'm going to have x is equals to v minus u over 2a. That would be how I would go about it. That would be how I would go about it. Basically, that's it. The second part of my video has something to do with conversion of units. It's much easier to convert, for example, grams to kgs. Just know the ratio, the fixed ratio. But sometimes it can be a little bit difficult to convert like it is in our question there. So I'll simply say question, convert each of the following as below. So convert each of the following as below. Therefore 2.1 grams per cubic centimeter to kgs per cubic meter. This is actually density. Okay, it's actually density. Therefore, how do you convert this to that? This unit here is a composite unit. There is mass and there is volume. There is mass and there is volume. This expression here, this measurement, remember, a measurement is a number to which a unit is attached. A measurement is a number to which a unit is attached. The number part gives you or tells you the magnitude of that measurement. Then the unit part tells you the physical quantity that is being measured. The unit part gives you the physical quantity being measured. Therefore, this is density, and this is 2.1. Okay, 2.1 is quite, I would say, a small number. compared, for example, to relatively to maybe, for example, 9.1 grams per cubic centimeter. So this tells you the magnitude, and this tells you the physical quantity being measured. So express this or convert this one to kgs per cubic meter. This is 2.1 grams. Therefore, whatever this substance could be, this density is trying to tell us to say 1 cubic centimeter of this substance, let's call it X, of this substance X, who have a mass of 2.1 grams. Therefore, what mass would what mass would 1 cubic meter of this substance have? So density is mass per unit volume. The mass of a substance whose volume is known, therefore mass over volume, mass over volume, mass per unit volume. So I'll simply convert, I'll convert 2.1 grams to kgs, and then I'll convert cubic centimeters to meters. This is 2.1 grams per cubic centimeter. Therefore, this is the same as 2.1 grams over 1 cubic centimeter. So convert the top part first and then convert the bottom part first. This will apply to almost all units that will have such kind of an arrangement. So I'll convert those grams to kgs. Remember, 1 kg is equals to 1000 grams. So 2.1 divided by 1000 will give you the kgs. The answer here is 2.1 times 10 to the power negative 3 kilograms over, the kilogram has actually set itself. Okay, I can even say over, I remove this, over 1 cubic meter is equal to 1 million cubic centimeters. So we're going to say 1 divided by 1 million, okay, which is going to give me 1 times 10 to the power negative 6 cubic meters. 1 cubic meter is equals to 1 million, is equals to 1000 grams. Then 1 cubic meter, that's volume, is equals to 1 million cubic centimeters. Those are the relations I'm actually using for me to convert the top part and the bottom part. So once we have that, we can easily say 2.1 exponential minus 3 divided by 1. So dividing those two values there, we have a 2.1 exponential minus 3 divided by 1 exponential minus 6. My answer is coming out as 2100 kilograms per cubic centimeter. This tells you that 1 cubic centimeter of this substance will have a mass of 2.1, and 1 cubic meter of this substance will have a mass of 2100 kilograms. That's what the density is all about. Therefore, a cubic meter would mean a box that has got all the edges 1 meter in terms of length, 1 meter height, 1 meter breadth, 1 meter length. All the edges are 1 meter. So I've converted that one. Coming to the second part, they have put 40 kilometers per hour, converting it to meters per second. This means that in 1 hour, this object which is moving will cover 40 kilometers in 1 hour. Therefore, this is actually 40 kilometers in 1 hour. Therefore, I'll convert the top part to meters, then I'll convert the bottom part to seconds. Then I'll divide the magnitudes. Therefore, this is kilo, meaning this is actually 40,000. 1 kilometer is equals to 1000 meters. That is 40,000 meters. Remember, 1 kilometer, small letter k, is equals to 1000 meters. Then 1 hour is equals to 3600 seconds. So I've converted the top part to meters. I'm converting to this. Then I have to convert the bottom part. So therefore, I have 3600 seconds. We have the meter per second, so we do the division here. We'll say 40,000 divided by 3600 will give me 11.11 meters per second. So if you have to measure this distance or convert this distance in meters per second, you have a speed of this much. and if you have to leave it in kilometers, you have a speed of that much. So that's how you go about it. If you want to reverse this to that, I think you have the idea now, but basically that's how you go about when it comes to converting compound units or measurements. Thank you for now. Remember to subscribe and leave your comments down below. Bye bye.